Hello everyone, welcome to our part 2 video about area. Yesterday we talked about the area of parallelograms and the area of triangles. Alright, that's part 1. So if you haven't gone through those lessons already, I would encourage you to do that before this one. Today we're going to talk about the area of trapezoids and the area of regular polygons. Alright, first we're going to talk about trapezoids. Alright, trapezoid is unique. It has a weird looking formula, but actually makes a lot of sense once we're going to look at it real quick. All right. Now, before we do that, all right, we have a couple different things. So for a trapezoid is the shape that only has one set of parallel sides. All right. It's a quadrilateral. It has 4 sides, but it's different from a parallelogram because it has only one set of parallel sides. Notice these 2 sides in yellow are not parallel. All right, so there's only one set of parallel lines. All right, what that means, all right, and how this changes for us a little bit is it changes what the base is. All right, if we remember yesterday for parallelogram or a triangle, a base could have been any of our sides. Well, for a trapezoid, that's not the case. All right, for a trapezoid, it is the 2 parallel sides are the base. All right, so it's always the 2 sides that are parallel or the 2 sides that will never intersect. All right, so we got them here and here, there and there, there and there. All right, so for those three examples that they give us right there, all right, it's the top and bottom. All right, it won't always be that way though, because notice if I draw one this way, all right, my bases are here and here. All right, because those are the 2 sides that are parallel. So just be careful. Realize that it's not necessarily the top and the bottom, but it's the 2 sides that are parallel. All right, other nice thing to note, all right, is that the sides that aren't parallel are called legs of the trapezoid. All right. And as we talked about yesterday, we have this wonderful thing called the height, and it's perpendicular to the base. In this case, since there's 2 bases, if we look in each one of those, the bases aren't the same length. All right. It has to be perpendicular to both. All right, so if you look down there, there's 3 questions there for you to answer. Isosceles for a triangle, I'm going to help you with number 3. All right, is a triangle where 2 sides are the same? Well, a trapezoid, it's very similar, it's a trapezoid with 2 sides that are the same. All right, however, the bases aren't going to be the same because the other 2 sides aren't parallel. So the bases have to be different lengths. So that's when the opposite sides or the legs are the same length. All right. And here they show you a nice picture. Basically what this is showing, all right, is they're taking a trapezoid, as we see right there, and they're taking its base, 1, they're adding it to its base 2, so it's saying, hey, the base of my trapezoid is base 1 plus base 2. Well, the height is still the height, all right, and notice we get that resulting rectangle. Now, in that resulting rectangle, there are not 1, 2 trapezoids, just like when we talked about yesterday there were 2 triangles, so we take half the area of that rectangle. That results in the formula, the area of a trapezoid is 1/2, or half of that rectangle we just drew, base 1 plus base 2, because that's the base of my rectangle. All right, that's the base right here, times the height, which has to be perpendicular to both bases. All right? And that's how we get that formula. All right? Moving on down here. All right? There's 5 different examples down there that are already worked out. I'm not going to show you all of them. I'm just going to kind of work a couple and then show you the main other points of the other one. All right? This first one, it's just straight. They give you everything. All right? They treat 5 as base 1, 22 as base 2, 4 is the height. Plug it in 1/2 times parentheses 5 plus 22, which is 27, times 4. All right, you can multiply those in order. So most people, I would try to do the 1/2 times 4 first, which is 2. 2 times 27 is 54 centimeters squared. All right, so that one's just showing you how to plug it into the formula. All right, now the second one, all right, a little bit different. Notice we have a little bit of square here plus a triangle on the far side. So you could just take the area of the square plus the area of the triangle, and that would work. But they're treating it as a trapezoid, so they have base 1 up here, they know is 8. Base 1 equals 8. They know this is 8, and that's 14. So base 2 is 8 plus 14, or 22. And then the height, it's just 8, because there's a right angle here too. So our equation is 1/2 8 plus 22 times 8, and that comes out to be 120. All right. Third one over here is a little bit tricky. All right. We know the height is 5. All right. Base 1 is 8. We don't know base 2, but we know part of it's 8. We need that part right there. Well, notice right triangle here. So Pythagorean theorem. 13 is hypotenuse, so 13 squared equals the height, which is 5 squared plus x squared. If we solve that out, it's 169 minus 25, which is 144. The square root of 144 is 12. So base 2 equals 12 plus 8, which is 20. Plug it into the formula. 1/2 8 plus 20 times 5 comes out to be 70 square centimeters. All right, fourth one down there just looks a little funky because they drew the height outside of the trapezoid, but that's okay. That's just your height because it's perpendicular to both. Base 1 and base 2 are interchangeable, so I could call this one down here base 1, that top one base 2. All right, just a habit most math people are in for some reason is they call the shorter one base 1 generally and the longer one base 2, but it doesn't matter. All right, 3 plus 11 is 14. All right, half of 14 is 7. 7 times 4 is 28. All right, last example right here that's worked out. Then you got 3 down there that you can try on your own that have the answers down there. All right, this one we need to find the height. All right, so we want to find h. We have base 2 here, base 1 up there. All right, but in order to do this, we need to take this triangle right here, which is 3 and h, and we want to find what that is. Well, if we look at it, we know the sides are the same, because right here, so those triangles on the side are the same triangle. We know this middle part is 6, so if these are the same on both ends, it has to be 1 and 1. So 1 there. Or 1 squared plus h squared equals 3 squared, what we see right there, which is 9 minus 1, which is 8. The square root of 8 is about 2.83. We plug it into our formula, and they get the answer of rounded 19.81. All right, so there you go. If you are looking at these for extra practice down here, all right, you're going to have to use Pythagorean theorem on all 3 of them. All right, you're going to have to use Pythagorean theorem to find the height here. All right, Pythagorean theorem to find this part, and double it and add 9, and Pythagorean theorem to find the height there. All right, so if you have any questions with that, as always, please let me know. All right. Next, we're going to move on to regular polygons. All right. This is the last set of notes for this week. All right. And for regular polygons, it's going to look kind of funky, but I'm going to do my best to explain why it is right there. All right. So remember when we talk about regular polygons, that means all the sides and the angles are the same. All right. All the angles are congruent. All the sides are congruent. All right. Well, there's a couple important pieces of information here. We have what is known as the radius. All right. Kind of like the radius of a circle. It's from the center out to a vertex. Center to vertex. So a center to one of the angles on the outside. All right. The other thing we have is the apothem, which is from the center to the midpoint of a side, and it's perpendicular. So it's kind of sort of like our height. All right. It's this distance right there. All right. All the other ones that you see drawn there are radii because they all go to the corners. All right, the apothem is that one that basically splits it in half. All right, so basically what we're going to try to do to find the area of these is we're going to find the area of one triangle, and then there's 1, 2, 3, 4, 5 triangles, so we're going to take 5 times the area of a triangle, because there's 5 triangles. All right. Now, here's how we do that, and here's where the weird part of the formula comes in. All right. If we notice, all right, in order to find the area of a triangle, it's 1/2 base times height. That part right there is the triangle. All right. Now, if we look over, at the picture, all right, my height is the same thing as the apothem. So we're going to replace h with the apothem. So instead of h, it's going to be an a. Our base is the same thing as one of the sides. So we're going to place base with the length of a side. Now notice there's 5 sides here, so it's a pentagon. The number of sides is just our number of triangles. Those are the same. And obviously the 1/2 is the 1/2. All right? So, a lot of us, the one formula is 1/2 ANS, or ANSA. You'll hear it a lot of different ways, but it's 1/2 times the number of sides times the apothem times the length of one side. All right? The other way you might see this is 1/2 P times A, which is 1/2 times the perimeter times the apothem. All right? Notice apothem is little a, or lowercase a. All right? The reason for that is because the number of sides times the length of one side is the perimeter. So we're just replacing n times s with perimeter. All right? Do I care how you use it? No. It's up to you which one of those you want to pick. Me personally, I use 1/2 NSA all the time. 1/2 times the number of sides times the side length times the apothem. Because a lot of times that's what they're going to give us. They're not actually going to give us the perimeter. If they gave us the perimeter, they just told me the perimeter and what the apothem was, I would probably use 1/2 PA. Right? But if I have to pick between one or the other, and one way is not easier, I'm generally going to pick the second one, where it's 1/2 ANS, NSA, SAN, however, whatever order you want to put the apothem, number of sides, and side length in. All right. If you look down here, there's a couple more options. All right. And it's just showing how we do it. All right. This first one right here, this is a hexagon. So that means there's 6 sides. All right. Each side is 12. So the perimeter is 72. That's how they do it. If I was working this out, I would do 1/2 times 6 times 12 times the apothem. So this would also be times 10.4. Sorry, guys, I ran out of room. Regardless of how we set that up, whether you find the perimeter or you plug it all in and multiply at once, you're going to get 374.4 units. All right, and a lot of times with these, you might get decimals. All right, that's okay. All right, same thing on the second one. This one is a octagon, so that means there's 8 sides. Notice the 8 there. Each side is 6.9, so the perimeter is 15.2. They take 1/2 the perimeter times the apothem and get 229.08. All right. Once again, the other way we could do that is we could just go 1/2 times 8 sides times 6.9. All right, times 8.3, and just multiply it all at once. It's not going to make a difference in our answer. All right, it might make a small rounding difference, but you're going to get basically the same thing. All right, down there we got 3 that you can try. They give you the apothem and the side length for all of them, so it's just plugging into whichever formula you decide you want to use. All right. As always, if you guys have any questions, feel free to let me know. I hope everything is doing well. And if you're in my class, we have Zoom meetings available, like same schedule as last week. All right? Sounds good, guys. Have a great day, and hope to talk to you soon.